So we are going to the next phase, or let me call it part 2 of activity-based costing. And in this case, we are looking at examples. So we want to look at examples. How do we solve questions when we have activity-based costing scenario? Remember, we said activity-based costing helps you to calculate the cost per unit of a product. Helps you to calculate the cost per unit of a product. So let's go and read through an example. So I hope we can see this example, which we had introduced it earlier in the previous session. So there is this example that we want to solve. So let's read it once more. We had already read it before. So we are in example on activity-based costing and absorption costing. So we are being told X Limited makes 2 types of high quality products. One product is called the light and heavy. Details. So there are 2 products, the light, which is abbreviated as L, and the heavy, which is abbreviated with letter H. Details of the 2 products are as follows. You have L and H production units, 10,000 and 5,000. We have direct material cost per unit. Cost is money. So it's dollars. But next, take note, it is direct labor hours per unit. Labor hours per unit is 1.5 and 1. Machine hours per unit is 2 and 3. Additional information, direct labor costs $8 per hour, and labor hours for the period are budgeted at 20,000. Machine hours for the period are budgeted at 25,000. Production overheads are estimated as 260,000. So the overhead costs are 260,000. An analysis of the production overhead establishes that these costs arises in relation to 4 activities in the following proportions and has the following associated volumes. So you have order handling, setup, material handling, and quality control. So you have been given all these. These are basically the cost pools, cost drivers. And then required is calculate the cost per unit for each product using traditional methods of absorbing overheads on the basis of labor hours. In other words, you have been told traditional method using labor hours. So don't use machine hours, only use labor hours in part A. In other words, calculate the cost per unit using absorption costing. Part B of the question, calculate the cost per unit using ABC principle. So we will start with what you have been told to use first. So in our solution to the question, so we will start with cost per unit, and we are using absorption costing. Which uses labor hours. It uses labor hours. So we want to look at what is the cost per unit using traditional method. Remember, this is the traditional method. So in this case, we will have maybe product L and we will have product H. So we want to look at the cost per unit. In order to get the cost per unit, we said it's direct cost plus indirect costs. Direct costs are also known as prime costs. So let's start with prime costs or direct costs. So we'll start with direct material cost per unit, cost per unit. It is $8, and so it is in dollars. So direct, it is 8. And this other side, it is 16. I'm just picking it directly from the question. 8 and 16. And you can see it is dollars. Okay, next we add direct labor cost per unit, which is also in dollars. Direct labor cost per unit. You can see here you are given direct labor hours per unit. These are not costs, this is hours, 1.5 and 1. But in the additional information you are told, direct labor costs $8 per hour. For product A, it was 1.5 hours. So what you do to get the direct labor cost per unit, you will take 1.5 times 8. Sorry, times 8. Remember, this was 1.5 hours. You multiply by 8 to give you 1.5 times 8. So to give you 12. Okay? And this other side, we have 1 hour times 8. Remember, I want to get the labor cost per unit. 1 hour times $8 per hour. So that gives you 1 times 8. So it gives you 8 again. So when you add these two, there were no expenses given in this question. So when you add these two, it's what gives you prime cost. Prime cost. Prime cost is also known as direct cost per unit. Prime cost is also known as direct cost per unit. So you are told the accounting treatment, whichever method you use, is the same. Now, after you have got the prime cost, you come and add to the prime cost, you come and add overhead costs. Overheads are indirect costs. Overhead cost per unit, which of course is in, again, dollars. Now here, we'll have to do some workings. I'll call it working 1. We will do some working to enable us get it. And then when you add overheads to the prime cost, that is what gives you total cost. Let's just call it cost per unit. Total cost per unit, which of course is also in dollars in this question. So that is how we will get it, but we are not done. We are still about to account for overheads. And then now I'll come for my workings, and I'll have working 1. I want to calculate overhead cost per unit using absorption costing, and we are using labor hours. We are using labor hours used to apportion. Or, okay, I can explain it down here. So we want to calculate the overhead cost per unit under absorption costing. So under AC, labor hours are used to apportion overhead costs to product L and H. So under AC, all labor hours are used because we were told to use labor hours. Now, please, let's be attentive. So what is the total overhead? cost. Total overhead cost, which of course is in currency form. Our total overhead cost, production overhead, are estimated at 260,000. So our total overhead cost is 260,000. You have it there. Now we want to share these to be shared using, so to be shared using labor hours. That is our objective, to share these 260,000 using labor hours. Now, what is the labor hours? Total labor hours. The total labor hours is equals to, for product L, the total labor hours are 1.5 hours per unit times the number of units. 1.5 times 10,000 units to get the total number of hours for product L. Let me cut that and come and post it there. Okay. I think it is clearer if I post it there. So total labor hours for L is that. Total labor hours for H is 1 times the number of units of H is 5,000. Okay, so what does this give you? It gives you 1.5 times 10,000. And this other one gives you 1 times 5,000. So that gives you the total labor hours. Labor hours is equals to 20,000. Hours. 20,000 hours. Let me round off. So these 20,000 we were even given in the question here. Direct labor hours, $8 per hour, and labor hours for the period are budgeted as 20,000. Now I need to get what is the overhead cost per unit. Overhead cost per unit of product L. Look at how I'm doing it. I'll take 15,000 over the total times the overhead costs. So I'll take 15,000 hours divide by 20,000 hours. We are apportioning using labor hours times $260,000. $260,000 is the overhead costs. So that is what we have in this case. So whatever value we get, we can be in a position to get the overhead costs. Sorry, overhead costs, not per unit. Per unit, so that is the overhead costs. Per unit, you divide by number of units. So overhead costs of L is that. Now, what do we get it? Let's calculate it. 15 over 20 times 260. So it gives you 195,000. Again, I repeat the same. Overhead cost per unit now. Overhead cost per unit of L. Now, per unit, you will take 195,000, which we have got, divide by the number of units is 10,000. Divide by 10,000 units. So That is dollars. Divide by 10,000. So this is 195 that we are talking of. So what does it give us? It gives us 195 divided by 10,000. So it gives you 19.50. That is overhead cost of L. Let's repeat the same for H. What is the overhead cost of H? Overhead cost of H is 5,000 over 20,000 times, again, the same cost. So it will be 5,000 over 20,000 times 260,000. 260,000. So what will that give us? 5,000 over 20,000 times 260,000. It gives you 65,000. It gives you 65,000. What about per unit? Overhead cost per unit of H. Overhead cost per unit of H. You will now take the cost of 65,000. You'll divide it by the number of units of H is 5,000. We divide by 5,000 units to get the overhead cost per unit. So that will give you 65,000 divided by the number of units, which are 5,000. So that gives you 13. 13, it gives you 13. So what we have, we are in need of that value there and that value. So those are the figures we need to complete the costs here. So what was the overhead costs? For L, the overhead cost per unit was 19.5. For H, the overhead cost per unit is 13. So with that, we are in a position to get the cost per unit. So what is cost per unit? It is the prime cost plus the overhead costs. Here it is prime cost plus overhead cost. So that's how we calculate the cost per unit under traditional method. Traditional method is known as absorption costing. So that's how we calculate under absorption costing. Okay, so that was under absorption costing. But part B was asking us, let me copy the same so that we can be fast. Part B was asking us to calculate the same under activity-based costing. So I'll call this, I'll change it now to B. B, I'm getting cost per unit now under activity-based costing. Under activity-based costing. And under activity-based costing, we use cost pools, and cost drivers. That is what we use. We use cost pools and cost drivers. Now, we said prime cost remains the same. The difference between AC and ABC is on how you account for overheads. So that leads us to working number 2. How we account for overheads in working number 2. So how do we account for overheads? We come here and have workings, and then we have working number 2. Workings, and then we'll have work number 2. Working number 1 was overhead cost per unit under absorption costing. Working number 2 will be overhead cost per unit under activity based costing. Now, we said under ABC, comma, overheads are shared out, are apportioned, in other words, using cost pools and cost drivers. Overheads are apportioned using cost pools and cost drivers. We explained it in the previous part when we were looking at the theory part in part 1 of this. We are in part 2, which is solving an example. So overheads. Now, in order to answer this, we will need to have a column known as cost pool. We will have another column known as cost driver. Cost driver is the basis. We will have a column for total amount of the overheads, of course. We will have product L, sorry. We'll have product L and we'll have product H. Product L, and we will have product H. So that is what we will have in order to answer the question well. Okay, so here you'll need to be very careful and attentive so that we get the difference. So under activity-based costing, this is what you will need to answer the question. Just a second, please. Okay, so what are the cost pools in the equation? Remember, we said the cost pool is an activity that consumes resources. So the total overhead cost was 260,000, but you are told to share them in these proportions. 24% goes to order handling, 38% to set up costs. So we have order handling. So cost pool, order handling costs. You are being told it is 38%. Sorry, it's 24%. 24% times 260. Of course, 260,000. Just allow me to take my time. Next is setup costs is 38%. Setup costs is 38%. I'll try to be taking my time, times 260,000. The total overhead costs, remember, it's 260,000. The third cost is material handling cost is 18%. Material handling cost is 18%. Of course, times 260,000. The overhead cost is that. The next cost is quality control. Quality control. What percentage were we given? 20%. 20% times 260,000. So that is the first part. So let me get those percentages before we go to the next item. So 24% times 260. Remember, the cost was, total overhead cost was 260,000. Let me put it here. Total overhead cost is 260,000. Is 260,000. So we have it here is equals to 24% times the 260,000. The next one is 38% times 260,000. The next one is 18% times 260,000. The last one is 20% times 260,000. So this gives us total overhead costs of that amount. So now we want to share out, please understand me. This is the total overhead cost of 260,000. Now we want to share out these overhead costs to product L and product H. And when we are sharing them out to product L and product H, let me do something here. And also that when we are sharing it out, we will be using the appropriate cost drivers. So let's check in the question if we were given each cost driver. Order handling. Order handling, the cost driver you are given is number of orders. Number of orders processed. So this is number of orders processed. The next one, setup costs, you are given number of setups. Number of setups. The next one we were given material handling cost. It was number of movements of materials. Number of movements of materials. Number of movements of materials. Number of movement of materials. The last one in quality control is number of inspections. Number of inspections. Number of inspections. Now you are given the number of orders in each case, number of setups. So let's go back. We start with number one. Order handling cost is 62,000. And what is the number of orders? We'll share the 62,000. Look at this. We will share these 62,000 to product L and H using number of orders processed. So let's come back to the question. The number of orders processed were 250. You can see here 250. Product L had got 167 orders. Product H had got 83 orders. So we share the overhead cost using this proportion, 167 and 83. 167. Now, Felix, you are asking me, how is 260,000 got? 260,000 was given in the question. Check here, Felix. Production overheads are estimated as 260,000. Felix, are we together? It is in the question, 260,000. Can you respond so that we move on? Is it okay? Can you respond so that we move on in the chat? Just say yes or no. Have you understood? Okay, let's move on. Okay, so we are on order handling costs, and the number of orders processed is 250. Product L was taking 167, and the other one was taking the remaining one. Okay, so let's go back after looking at, so we want to apportion using 167 and 83. 167 and 83. So look at what I'm doing here. For product L, we will take 167 divide by 250 times 62, 400. You get your answer. Here we have product H, it will be 83 over 250 times 62, 400. You get your answer also. So that is for the first product. And we repeat the same for all the other products. Setup cost, it depends on number of setups. So let's go and check the number of setups. Number of setups are 40 and 90. The total is 130. 40 and 90. Total is 130. 40 and 90. So 40 over 130, close the bracket, times 98, 800. You get your results there. This other side is 90 over 130, close the bracket, times 98, 800. You get your result also there. We move on. The next is material handling cost, number of movements. Material handling cost is number of movements. What are the number of movements? 67 and 33. 67 and 33. 67 and 33. 67 over 100 times 46. And this other one is 33 over 100 times 46, 800. And the last one is, quality control number of inspections, 287 and 193. 287 and 193. 287 and 193. So 287 over 480 times 52 and 193 over 480 times 52,000. So we have that. So, and then we will have, of course, we'll have our totals. And then production units, number of units produced. For each case, here the number of units produced was 10,000. And this other side, the number of units produced was 5,000. Let me see what is in the chart. Please, total overheads is given, but I am asking if practical. Felix, I'm not understanding your question. Total overheads is given, but I am asking if practical is a record of bills or is budgeted. Felix, here, we are assuming what was budgeted is the actual, unless you are told otherwise. You are assuming what was budgeted is what is actual, unless told otherwise. You assume what was budgeted was the actual result, unless you have been told there was a variance. However, we are not in the chapter of variances, so we use what is given. We assume what was budgeted was actual, unless you are told there is a variance. I hope I've answered you. So here we have 167 divided by 250 times 62. This other side, we have 83 divided by 250 times 62. The next one, you also do the same. 40 over 130 times 98. This other side, 90 over 130 times 98. We go to the next one. The next one is 67 over 100 times 46. This other side, we have 33 over 100 times 46. Next, we have 287 over 480 times 52. And this other side, we have 193 over 480 times 52. So we have calculated all the overheads. Now we get the total overhead for product L. It is 134. Total for product H, it is given there. Okay, so if I take the total overheads divided by the number of units, I get overheads per unit. I get overheads per unit. Also here, if I take the total overheads divided by number of units, what I get is overheads per unit. So we have, what is the overhead cost per unit? It is given there. So the overhead cost per unit is provided for you. So the overhead cost per unit is 13. And we have 25 under activity-based costing. So you come and place them there as working two. So here is 13.45. And here it is 25.09. And that is how we account for activity-based costing. In conclusion, we said that activity-based costing and absorption costing are techniques that are used to calculate cost per unit. Under absorption costing, overheads are apportioned using labor hours or machine hours. The higher of the two, the higher of labor or machine. But if you have been told to use labor hours, use labor hours. Under activity-based costing, overheads are apportioned using cost pools and cost drivers. Using cost pools and cost drivers. And that brings us, there is another example here which I want to leave for you as an assignment. 2 assignments will be there. You attempt them. After you have attempted them is when I will share with you the responses to that. So I'm giving you by Thursday next week. Attempt these 2 examples. I'm going to share with you the Excel sheet today through the WhatsApp group. You attempt them, and then Thursday next week, I'll see if I've calculated them to share with you the examples. Otherwise, that brings us to the end of today's session on activity-based costing. We will meet in our next session on Thursday next week, and we'll be looking at a different chapter. Thank you, and have a good evening.